Today we're going to finish up our notes from yesterday with the lesson 5.6, where in this lesson we are now graphing systems of linear inequalities, where we have, remember, two inequalities that have to be graphed on the same one. So here's our system of inequalities today. Y is greater than 3. 4y is greater than or equal to 5x. So these two look a little bit different, don't they? Y is greater than 3. What's missing in that one that we typically would see?
Slope.
Yeah, we don't have any x's, do we? So if we don't have any x's, is this in slope-intercept form already?
Yes.
How do we know it's in slope-intercept form? Because y is alone. So what's the slope of this line then? What would be the slope of the boundary line? It's 0, because there are no x's, 0 x's. So the slope is 0. And the y-intercept is 3. Okay, Justin, you do this on some paper. Come on.
But I don't have a graph.
Well, you're going to have to make your own. So in your notebook, you're doing this. Okay, so m is equal to 0, the slope is equal to 0, the y-intercept is 3, and we're ready to graph this one. Would it be a solid or a dashed line?
Dash.
A dashed line because we do not have the equal to bar. Okay, so y-intercept is 3. We start at 3 on the y-axis, put ourselves a point. We don't go, we have a 0 slope, so what does that tell us? Yeah, it's a horizontal line. So take basically this, when we have a 0 slope, that tells us we have a horizontal line. So we're going to just take our rulers, and through that point that we have, we're going to draw a dashed line that is horizontal. Oh, that's not a good one, not mine. Okay. And then we got to decide, should we shade above or below? What do you think? We should shade above or below. Y is greater than. Okay. So with your pencil, do a nice shading above the line. Let's see. That's not what I want. Okay, so we're going to shade above this horizontal line. We're going to shade lightly, right? Just like we did yesterday. Okay, and now we're going to take care of the other line, which is 4y is greater than or equal to 5x. Did we do a test point for that one? No. Oh, anybody want to stop me? Should we be doing that? Should we be doing a test point for this one, checking it out?
No.
Yeah, we should.
Yeah.
Let's go back and do it. So we need to do 8. What do you want to test?
0, 0.
Okay.
And it's false because it's out of the color.
Okay, and what do we want it to turn out? False or true?
False.
False, because here's the origin right here. So we don't want it to turn out true. So y is greater than 3. 0 is greater than 3. That is false. And so it verifies that we should have shaded the part that the origin is not in. Okay, now let's move on to the other one. Okay, so we are going to do what to both sides of this?
Divide by 4.
Divide by 4. Okay, do we need to reverse the inequality symbol?
No.
Why not?
So you did divide by
She didn't divide by a negative. Didn't divide by a negative. So we have y is greater than or equal to what?
5/4.
5/4 x. Okay. What's our slope?
5/4.
And m equals 5/4. B equals
0.
0.
Can you go back to the top?
Just a little bit. Okay, so we have our slope and our y-intercept. Should this be a solid or a dashed line?
Solid.
This one should be solid because we have the equal to bar. Okay. So let's go graph that boundary line. So where y-intercept is at 0, we have a 5/4 slope. So up 5 and over 4. Or down 5 and left 4. Where should we shade this time?
Above it.
Above it. What is above?
On the left.
So above is to the
Left.
left. Okay. So if we're going to shade above it, that would be to the, we believe is going to be to the left, so we will shade everything over here. Lightly. And then we'll check to see, we'll do a test point to make sure we shaded the correct side. Can we test 0, 0 this time?
No.
For this inequality? No, because it's on the line. So we can't test 0, 0 this time. What should we test?
1, 2.
1, 2 is, so 1, 2, that's kind of close to the line. Can we get a little bit further away from the line? How about we test this one right here? How about we test -1, -1? Can we do that one? Let's test -1, -1. So what we have is 4 times -1 is greater than or equal to 5 times -1. So we end up with -4 is greater than or equal to -5. True or false? -4 greater than -5? Yes. Okay. So since that's true, and since the point we chose does come from the shaded region, we can say we have shaded the right side, the correct side for this inequality. Okay, and now, last but not least, we have to decide where is the overlap. Where is the double shading going on? Right up in, okay, I'm going to get my, so, up in this region right here, here's where our double shading is going on. And we have one more test to do, don't we?
Yep.
We have
Shaded.
to test the double shaded region. So what point should we test from the double shaded region? Can't be the origin, can't be the -1, -1 we've already done. We're going to have to test something
0,
totally.
5.
0, 5? Okay, let's see where's 0, 5 at. Right here. So 0, 5 is in our overlap region, so let's test 0, 5 in both of them. So we have y is greater than 3, and we have 4y is greater than or equal to 5x. Okay, so y, our y value from this one is a 5. 5 is greater than 3. True or false?
True.
True. This one we have to put 5 in for y and 0 in for x. So we get 20 is greater than or equal to 0.
True.
True. Feeling pretty good about our overlap region. Okay, any questions?